right, guys, 12 practice problems, and then I will Google share with you the one-step inequalities test. So find the solution set, then graph on a number line. Let's start with problem number 1. X plus 15 is less than or equal to 27. So if this was an equation, what I would need to do is get this x isolated. So because it's x plus 15, I need to isolate x by subtracting both sides of the inequality by 15. So now that I've gotten this out of the way, does subtraction flip the inequality symbol? No. So it stays true. Therefore, x is isolated. We've got x is still less than or equal to 27 minus 15 is 12. Therefore, what we're telling x is you can be any real number as long as you are less than or equal to 12. Then you draw a number line with 0 in the middle, and you place that endpoint appropriately. In this case, our endpoint is 12. So 12 is to the right of 0 because it's positive. But remember, what is x allowed to be? Any real number that is less than or equal to 12. So 12 is my endpoint. And what numbers are less than 12? To the left or to the right? To the left. So we're going to shade all numbers to the left of 12. And when we reach the end of the number line, we go to infinity and beyond, to negative infinity and beyond, because we're going to the negative direction as well. Just plug in a random number. Let's go with 8. 8 plus 15 is 23. 23 is less than or equal to 27. It's less than. But let's go one higher, 13. 13 plus 15 would be 28. 28 is less than or equal to 27 would be a false statement. Therefore, that would not be true. But let's look at the endpoint now. Less than or equal to 12. Is 12 itself included in the solution set? Yes, so we fill it in. Okay. All right, anything that's shaded is true. Anything that's not shaded is false. All right, x minus 6 is greater than or equal to 8. If this was an equals problem, an equation rather, how do we get x minus 6 equals 8 to solve for x? We would need to add 6 to both sides. Does addition have any impact on this inequality symbol? No. So we cancel it out, leaving us with x is still greater than or equal to 8 plus 6 is 14. So as long as x is greater than or equal to 14, x is legal. So we're looking for the legal values of x. So we're looking at 14, which is to the left or to the right of 0? To the right. So let's just put 14 to the right of 0. That's going to be my endpoint, so I circle it. Okay. And what numbers are greater than 14? To the left or to the right of 14? To the right. So then, at the end of the number line, I put a big fat arrow to say that x is allowed to go to positive infinity and beyond. And greater than or equal to, is 14 itself invited to the solution set birthday party? Yes, so we shade it in. Okay. All right, so now 7x is less than 35. All right, so what do we do for 7x is less than 35? Well, pretend this is an equation. 7x equals 35. What would I need to do? Well, I would divide both sides by 7. Now, remember, the rule is tricky for flipping a sign when it comes to division. Did I divide both sides by a positive number or divide both sides by a negative number? I divided both sides of the inequality by positive 7, so this symbol stays true. So now I've got x isolated. 35 divided by 7 is positive 5. So as long as x is less than 5, we are good. So how do we graph that? Well, we look at the number line. We put 0 in the middle. Positive 5 is to the right of 0. So I'm going to circle that endpoint. And what values of x are less than 5, to the left or to the right? To the left. So we shade all numbers to the left side of 5. And once we reach the end of that number line, we go to infinity and beyond. X is less than 5. Is 5 itself invited to the solution set birthday party? What an odd theme, by the way. No, it is not. So we do not shade it. We leave that open. I'm just filling in those empty colored spaces. I'm sure I missed. But yeah, I just used a marker just to make it quicker. Okay, so anything that's shaded is true. Okay, now let's turn the page. Okay. All right, this time, 4/7 of x is greater than 12. So I've got a fraction in front of my x, so that tells me that I'm going to have to multiply both sides by a fraction. So if I'm multiplying both sides if I'm multiplying x by 4/7, ideally I would want to divide both sides by 4/7, but that's really confusing to divide a fraction. So instead what we need to do is multiply by its reciprocal. What's the reciprocal of 4/7? Well, the reciprocal means you flip it, or what multiplies the 4/7 to get 1. So in this case, if I multiply 4/7 by 7 over 4, I would cancel out and get 28 over 28, or cancel out 7 with 7. Sorry, I'll show it over here too. Right? 28 over 28 cancels out, becomes 1, or you can look at it like 7 cancels out with 7, and 4 cancels out with 4, leaving me with 1x. Either way, 28 over 28 gets you 1x. Now, I'm just going to do, right, well, what did I do? Did I multiply both sides by a positive or a negative? By a positive. So I multiply both sides by a positive, so the sign stays the same. And now I can simplify 12 over 1 times 7 over 4, because I can convert a whole number into a whole number over 1. So now I've got 12 times 7, I believe that is 84. 1 times 4 is 4. X is still greater than. If 4 goes into 80 20 times, then 4 goes into 84 21 times. So x, as long as you are greater than 21, you're good. You are legal to be plugged into this inequality and get a true statement. So how do I graph that? Well, where is 21? 21 is to the right, so I'm just going to put it over here just for reference. Again, it doesn't have to be exactly to scale. So x is greater than 21, so 21 is my endpoint. And if we're looking for all numbers greater than 21, well, where's greater than 21? To the left or to the right? To the right. So we're going to shade to the right, and once we reach the end of the number line, we're going to put a big, fat arrow to say we're going to infinity and beyond. Make that endpoint obvious. Is 21 itself invited to the birthday party? No, the endpoint 21 is not included in the solution set because there's no greater than or equal to. It's just greater than. Okay, number 5. Negative 4 is less than or equal to x minus 7. This time the variable is on the right side, but we're not afraid of it. So let's solve it like normal. Let's say this is negative 4 is equal to x minus 7. Well, if I want to isolate that x from x minus 7, well, what would I need to do? I'm still going to add 7 on both sides. Okay, so negative 7 cancels out with positive 7. Not too bad. Negative 4 plus 7 is positive 3. So now I've got the statement, oh, sorry, does adding on both sides have any impact on the inequality symbol? No, so it's still less than or equal to x. But I'm always very, very nervous when I see x on the right side. So whenever I see that happen, I like to start the sentence with x. I'm very comfortable with x on the left side. So if I start the sentence with x, so remember my shorter and taller example. If 3 is less than or equal to x, clearly x is bigger. So x is greater than or equal to 3 is another way of stating this problem. Okay, so how do I graph this on a number line now? So I've got a number line. I've got 3 to the right of 0. Right? I'm going to circle my endpoint. X is legally allowed to be all numbers greater than or equal to 3, so I'm going to shade to the right. And I'm going to put a big fat arrow. Okay, make your graph obvious. All right, now is 3 itself included in this solution set? Yes, because there's a greater than or equal to, so the endpoint itself becomes true. Think about it. Let's test this out right here. 4 minus 7 is -3, and -4 is less than or equal to -3. That's true. -3 would be bigger. 3 itself, 3 minus 7 is -4. So this whole right side is -4. -4 is in fact less than or equal to -4 because it's actually equal to. Go a little bit to the left, let's go with 2. 2 minus 7 is -5. -4 is less than or equal to -5. That's not true. -4 is actually greater than -5. All right, number 6. 2 is greater than x plus 19. Oh boy. Oh man. How do I do this one? Okay, well, I've got x on the right side, so that makes me nervous, but no matter. I'm going to treat this like an equation, but I'm just going to use, do I need to flip the sign or not? So if I want to get x isolated, let's say I'm focused on the x plus 19 portion of this problem. I want to get x isolated. So I need to subtract 19 from both sides. Positive 19 minus 19 cancels out, and 2 minus 19 is -17. And because I used subtraction, does subtraction have any impact on this inequality symbol? No. So it's still this. -17 is greater than x. I'm always nervous when x is on the right side. No matter, I'm going to start this sentence with x. So if -17 is greater than x, well then clearly this -17 is bigger. So I'm going to make x less than -17, still showing that -17 would be bigger than x. So that is my solution set. So now I have some graphing to do. So I've got my number line, 0 in the middle. Where is -17 compared to 0? It's on the left. So I'm going to put it right here. It doesn't really matter. I just need to see that it's to the left of 0. And now I'm going to circle that endpoint because it's important. All right. X is less than -17. Well, what numbers are less than -17? To the left or to the right? Okay. At the end of the number line, I'm putting a big fat arrow. And let's pick a number in the, is -17 itself included in this solution set? No, it says less than, not less than or equal to. So give me a number to the left of this. Let's go with -18. -18 plus 19 is a 1. 2 is greater than 1. That's true. So therefore, it's part of the red region, it's part of the shaded region, so it's true. -17 itself. -17 plus 19 would be 2. 2 is greater than 2. That would not be true because it needs to be greater than or equal to. Let's go barely to the right. -16. If x is -16, that'd be -16 plus 19, which would be 3. 2 is greater than 3. X equals -16 would be a false statement, so therefore it's not part of the solution set. Okay, now going on to number 7. Sorry, notebook. There we go, much better. Ooh, -6x is less than or equal to 24. what would I need to do to solve for x here? If this was an equation, what would I need to do? Negative 6x equals 24. Well, I'm going to divide both sides of the inequality by negative 6. Now I'm using division, so I'm a little bit scared. Well, does dividing both sides by negative 6 have any impact on this inequality symbol? Yes, if you divide both sides by a negative number, the left side and the right side do not follow this inequality. It's no longer true. So I make a little note to myself and I say, hey, sorry about that red ink, where are you? There you are. Hey, this statement is no longer true. If I divide by a negative, the sign needs to flip. Okay, so let's get that part out of the way. So now x is isolated, and 24 divided by negative 6 is negative 4. So every value of x, to make this inequality statement true, the x value needs to be greater than or equal to negative 4. So now I've got 0 in the middle, negative 4, let's just put it on the left. Let's put it over here. All right, let me get my marker. That is my endpoint that I care about. X is greater than or equal to negative 4. So all numbers must be greater than negative 4. So I'm going to shade to the right. And at the end of my number line, I put a big, fat arrow. Okay? And is negative 4 itself included in the solution set? Yes. Greater than or equal to means that the endpoint is in fact included. Just to show you that this works, let's go with a number bigger than negative 4. Let's go with negative 3. Negative 6 times negative 3 is positive 18. Positive 18 is less than or equal to 24. That's true. 18 is less than or equal to 24. Let's go barely to the left. Let's go with negative 5. Negative 6 times negative 5 would be 30. 30 is less than or equal to 24. That is not true, hence why it's not shaded. Negative 4 itself, negative 6 times negative 4 would be 24. 24 is less than or equal to 24. Of course 24 is equal to 24. So that's why the endpoint is included in this solution set. 9x is less than or equal to negative 54. If this was an equation, what would I need to do? Well, I've got 9x, which is less than or equal to negative 54. So be careful. What do I need to do to get x isolated? Say it with me now. I'm going to divide both sides by positive 9. Dividing both sides by positive 9. And I clarify that I'm dividing both sides by positive 9 because I'm going to ask the question, does dividing both sides of the inequality by positive 9 flip this sign? No, because even though the output itself is negative, it's what you do to both sides that determines whether the sign stays the same or the sign flips. So now that I've got x isolated, this symbol is still less than or equal to negative 54 divided by positive 9 is negative 6. So legally, x is allowed to be any real number as long as it is less than or equal to negative 6. So I draw my number line, put 0 in the middle, then I've got negative 6 on the left. I'm going to circle my endpoint. X is less than or equal to negative 6. So let's focus on the less than part. What numbers are less than negative 6? To the left or to the right? To the left. So I'm going to shade to the left. And at the end of my number line, I put a big fat arrow. And I ask myself, hey, x is less than or equal to negative 6. Is negative 6 itself invited to the solution set birthday party? Less than or equal to means that the endpoint itself is included. I am a fat dot person. I'm going to make it really obvious that negative 6 itself is included. All right. Negative 77 is less than negative 7x. Oh, the x is on the right side. Oh, that makes me nervous. That makes me Ooh, that makes me quiver with fear. But no matter. Let's pretend this is negative 77 equals negative 7x. How would I get x isolated here? I'm going to divide both sides of the inequality by negative 7. So now, does dividing both sides by negative 7 have any impact on this solution set? Yes, the inequality symbol needs to change, because if I divide by a negative, the sign needs to flip. So therefore, I'm going to take this symbol, I'm going to flip it to a greater than, right? And now, negative 77 divided by negative 7 is positive 11. And now we've got x isolated. So now I'm going to play, now let's here we go again. So now I've got x on the right side, which makes me a little bit nervous. So if 11 is greater than x, what if I start the sentence with x? 11 is greater than x, which means x is smaller than 11. So x is less than 11 would be the solution to this problem. So I get x is less than 11, 0 in the middle. Well, where is 11 compared to 0? 11 would be on the right. So I'm going to circle this bad boy. I'm a fat dot person. All right, and what numbers are less than 11? To the left or to the right of 11? All numbers less than 11 are to the left. And at the end of the number line, we put a big fat arrow, and we ask ourselves, is 11 itself invited to the solution set birthday party? It doesn't say less than or equal to, it just says less than, so the endpoint itself is open. It's not shaded. Okay, last 3 problems of the day, and then we'll call it a day. Okay. 8 is greater than or equal to 1/5 of x. Okay, well, x is on the right side, but luckily, how do I isolate x if it's 1/5 of x? I'm going to multiply both sides by 5. So in this case, to get rid of divided by 5, I'm going to multiply both sides by 5. Remember, what did I multiply on both sides? A positive 5 or a negative 5? Both sides got multiplied by positive 5, so the inequality symbol stays the same. So I've got 40 is greater than or equal to x, and this kind of makes me nervous because x is on the right side. If 40 is greater than or equal to x, I can rewrite this problem as x is less than or equal to 40. I'm happy. X is less than or equal to 40, so I've got 0 in the middle. 40 is to the right, so I circle that endpoint. And now, less than 40 means I'm going to shade to the left. And at the end of the number line, I'm going to put a big, fat arrow. Less than or equal to 40. Is 40 itself invited to the solution set birthday party? Yes. So that endpoint is included. All right. Negative 9/7 of x is less than 18. So I want to get that x isolated. Negative 9/7 of x is less than 18. So if this was an equation, I would rewrite the problem as negative 9/7 of x is less than 18 over 1, because I know that I'm going to interact with the reciprocal here. But remember, I want positive 1x. So what do I need to multiply on both sides of the inequality? Well, I'm going to multiply both sides of the inequality by the reciprocal, negative 7/9. The reason why is because a negative times a negative makes a positive, and 7/9 times 9/7, that'd be, you can look at this as 63 over 63. Either way, you're getting positive 1x. But remember, did I multiply both sides by a negative or multiply both sides by a positive? I multiplied by negative, so the sign needs to flip. Multiplied by negative, sorry, make that a little bit clearer. So the sign needs to flip. Now, I'm going to flip this less than sign to a greater than. Here we go. Now I'm going to multiply 18 times negative 7. Let me get my calculator out because I'm not very good at 18 times 7. Okay, 18 times negative 7 would be a negative 126 over 1 times 9, which is 9. And then I get my calculator and I divide by 9, and that would be negative 14. So x is greater than negative 14 is the solution set for this problem. So now where is negative 14? To the left or to the right of 0? To the left. So I put negative 14 over here. If x is greater than negative 14, I'm going to circle my endpoint. What numbers are greater than negative 14? To the left or to the right of negative 14? To the right. So I shade to the right. And at the end of the number line, I put a big fat arrow. And here we go. Good as new. All right, last problem, and I'll draw the number line a little bit lower. All right. Yeah, this is the ultimate test. Okay, so x is on the right. I've got negative 30 is less than or equal to negative 6/11 x. So take a deep breath, and we'll get through this together. Remember, we're solving for x. So what do I need to multiply on both sides to get x isolated? I'm going to multiply by its reciprocal. So if the reciprocal of 6/11 is 11/6, and I want to get positive 1x, I need to multiply both sides of the inequality by negative 11 over 6. So I can get a better angle on this. I'm just going to rip out the page. Oops. I did. So now I'm going to multiply both sides by negative 11 over 6. There we go. So now, what did I do? I multiplied both sides by a negative number, so this sign needs to flip to be greater than or equal to. Now that I've got negative times negative, that makes a positive. So negative 11 times negative 30 would be positive 330. 6 times 1 is 6. And now 11 cancels out with 11, and 6 cancels out with 6, and now we've got positive 1x. So now that we've got 330 over, 330 divided by 6 is 55. So 55 is greater than or equal to x. I don't like it when x is on the left side. So if 55 is greater than or equal to x, then clearly x is smaller. So I'm going to rewrite this problem as x is less than or equal to 55. And that is my solution set. Now to graph this. So if I put 0 in the middle, 55 would be to the right. And now, for the last time, I'm going to use my marker. x is allowed to be all numbers less than or equal to 55. So less than 55 means I shade to the left. Once I reach the end of the number line, I go to negative infinity and beyond. And is 55 itself invited to the solution set birthday party? Oh, you bet it is. So we fill it in. All right, so the test will be given after this video ends. It'll be due Tuesday at 11:59 p.m. The last test of the school year will be on absolute value inequalities in 2 steps. So if you know how to do a 2-step equation, this is the second to last test, and the next test will be on 2-step absolute value inequalities. Good luck.